When we have a performance problem in a page, the first thing we need to find out is what's slow. Without knowing what's slow, we can spend unnecessary time tuning things that have nothing to do with our problem, so knowing how to find the trouble spot is rather important. We'll first start by looking at the tools available to us in the different browsers. I'll be covering Firefox, Chrome, and IE. I won't cover Safari since it's essentially the same as Chrome. There are two main tools we will use to identify and diagnose performance issues: profilers and manual timing. Each of the browsers I mentioned has a profiler. This will be one of the main tools you'll use to identify performance problems. In Firefox and Chrome, there are three ways to call the profiler. The first and most obvious is to simply click the profiler button, which is right here in Firefox. In Chrome, the button is down here. The second way is to call profile and profile N from the console. In Firefox, the console is up here. Simply call profile and click run to turn it on, and then we call profile end and click run again to turn it off. In Chrome, we go to the console and type profile and then profile end to stop. The last way is in your code to call console.profile and then call console.profileEnd to stop profiling, wrapping the code that you wish to profile inside of those two calls. Internet Explorer's profiler can only be called from within the developer tools by clicking on the Start Profiling button, so it is a little more limited. Between the three profilers, there are some meaningful differences in what they produce as output. Let's look at a concrete example. I've created this sample page with some nested divs. I've attached to the hover event on each div, and each time the event is fired, it calls a series of nested functions and does some console logging. First, let's look at a profile of that in Firebug. Firebug produces a list of the functions called, and it gives you a few neat things. First, it gives you the total time spent executing JavaScript and the total number of function calls. That right there is often enough to solve your problem. By simply trying different combinations, this single pair of metrics can tell you how performant your code is. When you expand it, it gives you some nice numbers. For each function call, it gives you the total number of times that function was called, the percent of time spent in that function, the actual own time, which is the time spent only in that function and not in other functions called by it, the total time, the average, the min, and the max. Chrome's profiler is a little different. First, it doesn't give you the total time and total call count. In fact, the call counts are not given at all. And you can see the percent or time for both the total time and the self time, but nothing else. Also, it doesn't give you a list of all the functions called, but it does give you the ability to drill down into the call stack and see how the functions call each other. And it also has this neat bottom-up view that puts the bottom of the call stacks on the first level. It also has two very interesting features. One is the exclude function button, so that you can remove functions from the list that you don't care to look at. And the other is this focus button, so that you can focus on specific functions that you care about. Those can be very useful when looking at profile data. Lastly, IE's profiler can alternate between a function list, like Firebug, or a call stack, like Chrome, and it gives you call counts, but the time resolution isn't very good. You can add additional columns to see the average, max, and min time, and a few other things. The other main tool we'll use is manual timing. Thankfully in Firefox and Chrome there is a nifty time function that will report out an exact time. So, if we want to just time a function call, we can wrap it in a call to time and end time like this. Notice that the string describing our timing call is required and will identify it in the console for us. Now that we've looked over the main tools we'll use to identify performance problems, let's discuss the strategy that we should generally follow. Naturally, you should fit this strategy to your own needs. First, if we don't know which piece of JavaScript is slow, we'll start by profiling the entire page. Usually we do that by turning on the profiler, then using the page for a sufficient amount of time, and then ending the profiler. Then we look at the profile output and focus in on things like high call counts, high time percentages, high maximum call times, etc. We'll use this information to zero in on the functions that may be the biggest bottlenecks. Then we may optionally use manual timing statements to assist in identifying the problem. Once we have zeroed in on a few functions, we can then call the profiler in code using console.profile to look at specific functions in isolation. We may use some manual timings here in conjunction with or in place of the profiler. As we confirm that a function is indeed a performance problem, we may then try some alternate algorithms to see if the performance can be improved. At this point, we may possibly try some of the specific techniques that will be covered later in this module, or simply some trial and error. And lastly, we'll repeat this process as necessary until our performance becomes acceptable. As we do these things, there are a couple tips that we should keep in mind. Use named functions instead of anonymous functions. If you have an event handler and you use an anonymous function, replacing it with a named function is a good idea because in the profiler, you'll see the name of that function and not simply the words anonymous function. Also, isolate any AJAX or HTTP calls. The best way to do this is to try your page with all AJAX and HTTP calls initiated by your JavaScript, replaced by mocked calls that simply return instantly. This may show you that the problem isn't actually your code, but network time. Lastly, you should be familiar with the output of the profilers under different circumstances. It's a good idea to try some simple pages in each of the different profilers to learn how each profiler represents your code so that you aren't confused when looking at the results of complex production code.